Welcome back to part 4 of our live training session here with our Honda K-Series engine and AEM Infinity. In this training module, we're going to be exploring how to dial in our low cam part throttle area of operation. This is going to be where we have the majority of our time cruising. It's going to give us good economy, good drivability. We're going to make sure the fuel, spark timing, and variable cam control are dialed in 100% for this alpha end strategy with our individual throttle bodies. Without further wait, let's jump in so we can check this out. Welcome back to our live training session. We're going to be taking a look in this tutorial at how to dial in our part throttle calibration process in an alpha end strategy with our individual throttle bodies. So this process is pretty straightforward. It's very similar to what we've already covered in other live training tutorials, but it is a little bit different because we now have throttle position as the load input to our main VE table. Now we chose, in this case, to go about our spark timing using our map pressure sensor. If we flip over here, this is going to have our traditional map pressure input to our table. Now we can always switch this to throttle position if we're finding that this is not going to be consistent enough. However, spark timing has less of an impact in terms of what we're going in commanding at various different vacuum movements in our map pressure range compared to our fueling with our throttle position. So that's why I kind of have a hybrid alpha end style strategy going on here. We'll find that we can have a pretty similar spark timing value throughout our spark timing table and still have the engine run properly, but that is not going to be the case here with our volumetric efficiency airflow model. We need to make sure that this has been dialed in as best as we can. Now, we've set up some reasonable VE values in our table as a starting point. We know at idle, the values of 55, 60 were pretty close, and we didn't really adjust those. We adjusted our injector latency or offset to get our fueling correct. Now, when we're starting to drive and deal with our calibration process in this tutorial, we're definitely gonna have to adjust our VE values. These are not going to be perfect. They're just going to be a reasonable starting point. Now, one trend of the table that you're probably noticing is that our VE values here are higher in the lower RPM than they are compared to the higher RPM range. And this is relatively normal for any individual throttle body based vehicle doing an alpha end strategy. We're going to find we have lower VE numbers here at higher engine speeds at lower throttle angles compared to the lower RPM range at that same lower throttle angle. So we have more higher VE values here compared to lower VE values here. This is just the shape the table's going to take after you start to calibrate it. Now I put some, again, reasonable guesses in the table, but we do have to go through the process of dialing it in. Now, how are we going to do that? Well, what I'm going to do here is drive it in different driving cycles on the mainline chassis dyno. You do not need a dyno to do the part throttle calibration process. I'm just going to do this because I have it at my disposal and I'm going to able just do the driving cycles a little bit more rapidly in a controlled environment. But again, you can do this, let's just say on the roads near your home. It's not going to be anything that's going to require a chassis dyno to calibrate. What we're going to be paying attention to is what the lambda feedback is doing at any given time. We're going to log it, we're going to play back the data log, and utilize that lambda feedback to guide us in making our changes to the VE values in our VE table. And this is going to take a couple driving revisions, driving cycles to get this nailed down, but we should have at the end of this a solidly dialed in VE table from, let's just say, 60% throttle and below. The last bit of the table here, 70% throttle and higher, we're going to be dialing that in the next tutorial, looking at doing our wide open throttle low cam non-vtec tuning. So we're just focused on the low cam operation, not on high cam at this point. So the VE table 1, the way we've configured our base map is it's utilizing VE table 1 for low cam operation and VTEC activation. It's going to be switching over here to VE table 2. And this is the way that Honda always sets up all of their fueling and spark timing tables to the engine with an OEM ECU. There's always a low cam and a high cam because we have two distinct profiles with our cam. As we have low and high cam, or non-VTEC and VTEC, we're going to find two different airflow amounts and therefore two different VE profiles for our engine. And it's almost acting like two different engines. That's why we have these two different VE tables. So I always like to separate them. I like to calibrate low cam first, calibrate high cam then next. We'll be worrying about doing that calibration later on our high cam, or focus again just on our VE table 1. So 60 to, let's just say 0% throttle range. This is going to be what we're focusing on dialing in using that lambda feedback. Now, a couple of things additional with this. We've pre-populated our variable cam control table in part throttle conditions to have values at 2,500 to roughly 5,000 RPM at approximately 30 degrees variable cam target. This is putting some overlap in part throttle. Whether you're an OEM or aftermarket cams, I've always found that 30 degree works the best to give you a good compromise between fuel economy and torque and power output out of the engine, a good throttle response. So what I've done here, let's actually copy 50 into 60 here. I've pre-populated the table out. We have our values in here already. These are going to be good starting points. When we get into full throttle, we'll calibrate the last 3 rows here and figure out what the engine wants at that particular time. Again, we're just focusing on part throttle. So what I have in here should work for any K-Series engine to get good throttle response, good economy, and you'll be able to populate that into your base calibration file to kind of get things going with. So we have our variable cam timing parked. We'll have to verify that the engine's tracking the variable cam targets as we're looking through the data logs. We have our spark timing here being pretty conservative. We're really going to be focusing from 2,000 RPM, I would say, for probably to 7,000 RPM. We're going to be focusing in this area right here. Now, these spark timing values at anywhere between 14 to 20 degrees are conservative. This is a high compression engine. I don't know exactly where the spark timing is going to be at. We probably are 10 to 15 degrees lower in spark timing right now than what we ultimately will run on the engine. Once we've dialed in our VE table and our airflow model here, we'll go back in and dial in the spark timing at a later point in time in this tutorial. Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.